Hello learners, welcome back to my channel Shraddha's Physics. In this lecture we will see the reciprocity theorem of mutual inductance. Now let us start our topic with the reciprocity theorem of mutual inductance. We have already discussed about the mutual inductance, that is, if in one coil there will be a current, then because of this current flowing through this coil there will be a magnetic field, and if another coil is given by insulation, so because of this coil, suppose there is another coil, this one. Now because of this first coil there will be a magnetic flux that will be linked with the second coil, and when the current in the first coil will changes, then there will be change in the magnetic field, and so that the change in magnetic flux can be felt in the coil 2, and because of that change in magnetic flux, according to Faraday's law, there will be an induced EMF will be developed. So this total phenomenon is called as the mutual inductance. Now let us consider there are two closed circuits. Suppose these are two closed circuits. Let us consider there are two closed circuits. Two closed circuits that is, suppose C1 and C2 are situated close to each other, and carrying current. Suppose in the first coil this is suppose C1 and this one is suppose C2. Suppose the current in the C1 coil is suppose I1 and the current in the C2 coil is suppose I2. This suppose I2. Close to each other and carrying currents I1 and I2 ampere respectively. I1 and I2 ampere respectively. Now the current in the coil C1, that is the current is I1. The current I1 in the C1, it will cause the magnetic flux linked with this coil C2. Let the current I1 in C1 coil will cause a magnetic flux linked with the coil C2 If B is the magnetic field, caused at a point in circuit or in the coil C2 due to current in coil C1, then the magnetic flux linked with the coil C2 So now we can write the flux. The flux of this magnetic field through the loop 2 loop 2 means the coil 2 through the loop 2 of area ds2, suppose ds2 is suppose phi 2 1. So the flux in the coil 2 because of the current in the first coil, that is phi 1 is equal to surface integral over s2 b1 phi equal to b dot ds. So this will be simply b1 dot ds2. So here we can write, on the place of b1 I can write this is integration over s2. In place of b1 I can write b is the del cross a, this is the curl of a, this is a1 dot ds2, and here this a1 is the vector potential, a1 is the vector potential, a1 is the vector potential at C2 coil due to the current in C1, due to the current in C1. So here I have already told you this V equal to del cross A. So here we can write this will be equal to, according to the Stokes theorem, we can apply the Stokes theorem to convert the surface integral to the line integral. So this will be integration over the coil C2 A1 dot dl2. Here you can see in this two coil, if I will consider this is suppose surface area, it has the S1 and it has the surface area S2, and if I will cut a very small length, this is suppose dl1, this is in first coil, and here if I will cut a small length, then this is suppose dl2. So this is what we represent this phi 1 equal to a1 dot dl2 by applying Stokes theorem. So by applying Stokes theorem, and this dl2 is known as, dl2 is the current element of, C2, the current element of the coil C2. Now also we know the value of A1, but we know A1 equal to mu naught I1 divided by 4 pi, mu naught I1 divided by 4 pi into integration over C1, this C1 into dl1 divided by R, where R is the distance between two current element. R is the distance between two current elements. That is the dl1 and dl2 are the current elements. So the distance between dl1 and dl2 is R. So where R is the distance between the two current elements. Now we can write this phi 1 will be equal to, if I will put the value of A1 here in place of phi 1, so this will be integration over, let me write, this phi 1 will be equal to integration over C2, this is A1 dot dl. So in place of A1 I will write mu naught I1 divided by 4 pi integration over C1 dl1 divided by R whole into, this is the dot product of dl2. So this is the representation of phi 1. Here we have just substituted the value of A1. So now this equation can be more precisely written as this phi 1 equal to, or this phi 1 can be written as phi 1 is equal to mu naught I1 divided by 4 pi, these are the constant taken outside the integration over C1, and again the integration over C2 dl1 dl2, these are the current element, divided by R. This is suppose equation 1. And also we know the flux is directly proportional to the current, or we can write this phi 1 equal to M21 I1 M21 is the proportionality constant or known as the mutual inductance. So if I'll compare this equation 1 and 2, now what we'll get? This I1 coefficient, that is mu naught by 4 pi, double integration, that is one for C1 and another for C2, dl1 dl2 divided by r. This is the value of M21. So comparing equation 1 and 2, comparing equation 1 and 2, equation 1 and 2, the value of M21, this will be equal to mu naught divided by 4 pi integration over C1 integration over C2 dl1 dl2 divided by r. So now you can see, if I will compare these two equations, the value of M21, this will be equal to mu naught by 4 pi integration over C1 integration over C2 into dl1 dl2 divided by r. Or we can say that when there is a current, when there is a current in loop 2, if there is a current in loop 2, then the magnetic flux is obtained across loop 1, across the loop 1, or this is equal to phi 12, or this phi 12 equal to the magnetic flux through the loop 1 or C1 due to current in C2, due to current in coil C2. So this is the value of phi 12. That is equal to, we can write also, surface integral over S1. This is surface integral S1 B2 dot ds1. B dot ds is the flux, and here also we can write this is the integration over S1. In place of B2 we can write this is del cross A2 dot ds1. Here this B2 is the del cross A2, and again if I will convert it into the line integral by applying the Stokes theorem, then this is integration over C1. This is simply A2 dot dl1. Now this phi 12, this can be written as this phi 12 equal to integration over C1. In place of A2 we can directly write mu naught I2 divided by 4 pi integration over C2 dl2 divided by r. This is the value of A2 dl2 divided by r dot dl1. Here we have just substituted the value of A2, that is the vector potential, the value of it is mu 0 I2 divided by 4 pi integration over C2, the line integral, that is dl2 divided by r. This is the value of A2. We have just substituted this vector potential in this phi 12, and also this is suppose equation 3, and also the value of phi 12, that is equal to M12 into I2. So here if I will compare this equation 3 and 4 like equation 1 and 2, then here the value of M12 will be equal to, if you will compare this two, then M12 will be equal to mu naught divided by 4 pi integration over C1 integration over C2. This will be dl1 dl2 divided by r. This is the value of M12. Now if you will see this equation, you can see here the two equation, that is for M12 and M21, these two values are same. This is also mu naught by 4 pi integration over C1 C2 dl1 dl2 divided by r, and also it is here M12 will be equal to mu naught by 4 pi integration over C1 and integration over C2 dl1 dl2 divided by r. Since the current flowing through, current flowing through the coil, since current flowing through the coil 1 through the coil 1 through the coil 1 is equal to the current flowing is equal to the current flowing through the coil C2, current flowing through the coil C2, coil C2. So the flux will be same, that is phi12 equal to phi21, and also M12 will be equal to M21, and that is equal to, let us say, M. So by the principle of reciprocity, the principle of reciprocity means principle of reciprocity means mutual inductance is reciprocate from one side to the other, in equal manner, So this is the principle of reciprocity. So the principle of reciprocity means mutual inductance is reciprocates from one side to the other in equal manner. And also we should note that this mutual inductance M depends on depends only on the geometrical properties of the geometrical properties of the two coils such as the number of turns and the radii of the two coils, and the radii of the radius, okay, the radii of the two coils So the mutual inductance depends only on the geometrical properties of the two coils, such as the number of turns and the radii of the two coils. And since here the current flowing through the coil 1 is equal to the current flowing through the coil 2, so that phi12 equal to phi21, that is the flux linked with the first coil and the second coil. These are same. If the current is flowing through the one coil, then the flux linked will be on the second coil, so that there will be an induced EMF. And if the same current is flowing in the coil 2, then there will be the same magnetic flux in the coil 1, and hence there will be an induced EMF. And we can say that the mutual inductance, the value of mutual inductance is same for the coil 1 and the coil 2. This is known as the reciprocate theorem, or the reciprocate theorem of the mutual inductance. So this is all about the reciprocity theorem of the mutual inductance. Okay. Thank you all.